Good morning everyone. This is B Akila from CSM. Today my topic is band theory of solids. Now we discuss band theory of solids. What is band theory? Band theory states that in solids, closely spaced energy levels of atoms combine to form continuous bonds of energy which determine the electrical conductivity of the material. This is band diagram. Conduction band, valence band and band gap. 2 into n into r equal to n into lambda. Band diagram for conductors. According to band theory, in conductors, the valence band and conduction band overlap each other. Because of the overlap, electrons can move freely from the valence band to the conduction band, allowing easy flow of electron current. If a solid is conductors, it has either partially filled or completely filled valence band overlapping with conduction band. When a potential is applied across the solid from some of the electrons like to the conduction band, and hence it acts as a conductor. The forbidden gap is not present in good conductors. The electrical conductivity of a metal decreases with rising temperature because increased thermal vibration of the atoms cause scattering of the electrons, thereby obstructing their free flow. Band diagram for semiconductors. The band theory of solids explains electrical conductivity by categorizing materials into conductors, semiconductors, and insulators based on their electrical energy bands. For a semiconductor, conduction band, valence band, band gap, e.g. less than 3 electrical volt. If a solid is semiconductors, it has an almost filled valence band, empty conduction band, and a very narrow energy gap at 0 degree Kelvin. All semiconductors are insulators. As the temperature increases, the width of the forbidden gap decreases. Hence, some of the electrons jump into the conduction band. So, the electrical conduction of a semiconductor increases with rise in temperature. Band diagram for insulators. A band diagram of an insulator is representation of its electronic energy bands, showing a completely full valence band separated from an empty conduction band by a large band gap. Valence band, conduction band. The band gap e.g. greater than 3 electrical volt. If a solid is insulator, the valence bond electron are tightly bonded to their nuclei and require a very large electrical field. To remove them are called insulators. For example, diamond 6 electrical volt, glass 10 electrical volt, etc. At room temperature, there is no chance for electrons in the valence band to jump into the conduction band. Hence, those substances show the best insulating properties at room temperature. However, at higher temperature, some of the valence band electrons jump into the conduction band. Hence, the insulators exhibit conductivity the rise in temperature. Advantages. First, explains why materials are conductors, semiconductors or insulators. Second, helps understand temperature effect on conductivity. Third, useful in designing electronic devices. Disadvantages. First, assumes perfect crystals not realistic. Second, not accurate for complex or impure materials. Third, does not explain magnetic properties well. Thank you.